Another way we can evaluate limits is something called the squeeze theorem. And the squeeze theorem says if you have a function g, and we know we can figure out a function that's always bigger or smaller than that. So f of x is always smaller, and h of x is always bigger. Then we can evaluate this by kind of looking at what the pictures do. So let's say this is our function g here. Like we just said, f is always going to be smaller. H is always going to be bigger here, except right at the point we're looking, those limits actually end up equaling the same thing. Well, if H is always bigger and F is always smaller, but they have that same limit value there, that would force G to also have that same limit because you can't be less than and greater than something at the same time, which forces it to have to be equal to that value. Let's take a look at an example. We want to show that the limit as x approaches 0 of this function equals 0. Well, we can't just plug in our value of 0 here because that gives us dividing by 0. And none of our tricks like factoring, conjugate, or just trying to simplify that work. And so we need a different way. Well, we're going to focus on this part giving us trouble here and see what do we know about sine of 1 over x. Well, any sine value, we know the graph of sine always is going to alternate between 1 and negative 1. You've seen that graph before in trig. It's always going to stay between 1 and negative 1 and be this wave. So what we know is we can say this graph's always going to be between 1 and negative 1. Okay. Well, something else we know then is that we're trying to evaluate this limit. So let's try to get this inequality we have going, try to be the same thing. So now what we're going to do is add in this part about, or multiply this part about x squared. So we're going to times this by x squared, and then we're going to do the same thing to these outside. So now what we'd have is that x squared times sine of 1 over x would have to be, well, x squared times 1 is going to be x squared. And if we multiply x squared out here, we get the function negative x squared. So now this function that we have should always be between these other two graphs. And you can see that from here. Here's a picture of x squared. Here's a picture of negative x squared. And here, this red one here should be our graph of x squared times sine of 1 over x. And you can see it's always between those other two. Okay, so now our next thing, we want to show what's the limit of all these functions as we approach 0. So now we're going to add in the limit part. So what's the limit as x approaches 0 of this function? What's the limit as x approaches 0 of the function we're trying to look at here, which is x squared times sine 1 over x. And we're also going to then put in this limit as x approaches 0 for our right side function here of x squared. Well, the middle one we're still unsure on here. We still don't have a great way of figuring this one out. But what we can do is figure out these other two. Limit as you approach 0 of x squared, well, that just ends up being 0. Limit as x approaches 0 of negative x squared, that's also 0. And so now we have shown that this limit has to be equal to 0 because it can't be greater than 0 and less than 0 at the same time. It forces us to equal that it has to equal 0. And so what we can say is by squeeze theorem, that limit as x approaches 0 of our function here would in fact have to equal 0. And you can see again from this picture that because both of these are equal to 0 here, it forces our red function, which is this one, to have to equal 0 as well. All right, why don't you pause and give this one a go and see what you get. All right, let's see what you got. Again, in this one, looks like the part giving us trouble here would be that one. It's a cosine function there. So that cosine function, we know any cosine function here is going to have to be between 1 and -1 because the graph and cosine were always going to be between those two values. Let's get that part in there about x to the fourth now. So if we times by x to the fourth to both sides, we get these functions. Now we're going to take the limit as we go to 0 of all this. Our middle limit, again, we can't figure that one out, but we do know these other two here are both going to equal 0, and so similar to last problem now, that forces this to also equal 0. So by squeeze theorem, we could say that this function is also going to have to equal 0.